Welcome to my YouTube channel Techie Sang. Hi, this is Dr. Sangeeta. If you find my channel is informative, kindly subscribe my channel. We are going to discuss about key components and functionalities, application and its benefits, types of timer, counter hardware, and applications in embedded system.
The key components and the functionalities are counter registers. It stores the count of the events that occurred. That count is stored in the count register. The maximum possible timeout period based on its bit width. Prescaler. It divides the watchdog clock frequency to achieve longer time periods. To decrease the time period, what I will just do is that I will divide the clock frequency to retrieve to have longer time period in the watchdog time. This is possible using prescaler. So I have flexibility in frequency. Timeout register value. The initial loader value is loaded in the counter and determines when the timeout occurs. Control register. It enables or disables the watchdog timer. It configures the prescaler. Select the resource source, that is watchdog reset versus other reset sources. The interrupt generation is also supported in case of control register. The status register indicates whether watchdog timeout has occurred and information about the reset source. Kick or reset register, what it does is that key value must be returned to the reset watchdog timer counter. The applications and benefits is that it has reliability, improved system reliability, and availability. So, since it automatically recovers from faults automatically, whenever there is a crash in software or a crash in hardware, the watchdog timer will take care of it. So, automatic recovery from transient faults is possible. It reduces downtime and the need for manual intervention. Safety critical system. It is used in automotive, medical devices and industrial control. And wherever there is crucial of fault tolerance, this is used. Remote and unattended system. So if it is a remote system, you can also gather information from the remote system using these type of systems. That is also possible. Early detection of software issue. Whenever software bugs happens, the watchdog timer resets and it makes the software to come out of the bugs, come out of the crash. That is into infinite loop. So it saves the hardware also. Example for use cases is that automotive control unit, industrial automation, IoT devices, medical equipment, and aerospace systems. Types of timer counter hardware. High resolution timer. With very fine time resolution, high frequency clocks and advanced techniques can be used here. Wherever it requires precise timing, motor control, or high-speed data acquisition, high-speed resolution timers will be used. Programmable, the key features is that programmable period, the duration of time interval or period of waveform can be set. It compares registers to trigger the event at specific times because it stores the values in the registers. So it triggers according to the values that is available in the registers. Pulse width modulation. In case of pulse width modulation, generating variable width pulses for motor control, dimming LED, And also duty cycle and frequency, edge aligned and center aligned pulse width modulation. You can capture the input capture. How it works is that whenever specific event occurs at input, it will capture the value of the timer count. So it is used for measuring pulse width, frequencies, and time intervals of external signals. Output compare. The output signal or triggering an action when the timer counter matches a program compare value. Used for generating specific waveform delays and triggering other peripherals. In case of interrupt generation, timers and counters can generate interrupts on overflow, compare match, and or input capture events, enabling efficient handling of time based without continuous pooling. So pooling, it is very time consuming. If it is continuous pooling, this can be avoided in case of interrupt generation. Software considerations for timer counter. Initialization. That is, you have to initialize clock source, prescaler, counting mode, and interrupt setting. All this has to be initialized. All these registers has to be initialized. Register setting and driver libraries. Interrupt service routine. Handling timer/counter interrupts. It keeps ISRs short and efficient. That is, interrupt will be kept short and because to make it efficient. It updates the flags immediately after every task and scheduling tasks or performing immediate actions. Synchronization. It coordinates multiple timers or timers within the peripherals. So, if it is a complex system, you can ensure accurate timing. This is done with synchronization. Software timers. Using hardware timers, implementing logical timers using a single or few hardware timers. So, software timer manages use and expiration. Avoid common pitfalls. Incorrect prestate calculation leading to wrong timing and race conditions in interrupt control. It also ignores timing overflow conditions. The basic applications in embedded system is that real-time operating system. It does task scheduling on timer ticks, implementing delays and timeouts. And next thing is motor control, generating pulse width modulation signals both for speed and torque control, using input capture for motor speed feedback, communication protocols, implementing precise timing for serial communication, UART SPI 92C, implementing handling timeouts in communication protocol, sensor interfacing. What it does is that sensor output frequency or pulse width using input capture, generating timing signals for sensor activation. What user interface does is that delays of bouncing buttons, it implements it. It generates timing for display updates. In case of industrial control, precise timing for automation process, event counting for.
Thank you, friends.